know I am recording right now.
Thanks, Al. All right, I'll go ahead to the first slide then. Or did we do introductions last time or no?
Yeah, I think we did. Yes.
Let's do introduction, please.
Yep.
Okay, Rachel, why don't you take the lead on that?
Okay. Thank you, everyone, for joining this training. I am Rachel Hanskin. I'm the Permanent Water Quality Manager at CDOT headquarters. I would like to thank Al Gross and Neil Lacey, as well as Jesse Nolly and Amy Teagan for making this training a possibility. And I would like for everyone to introduce themselves and identify what region they're from as well, so that our trainers especially know who they are working with today. Al, would you please introduce yourself?
Yes, my name is Al Gross. I'm with CDOT Staff Hydraulics working for Neil. Just a little plug for Neil here. We've been working on this effort for what, Neil, about 1.5 years or so. And we're coming up at the end of this task order. And this is the reason why we want to do a training workshop. And this will be our second session. So, and again, this is being recorded. And if you want a copy of this, let me know. And there's a lot of information on the invite as well. A lot of different files that Jesse has provided. So I believe you have access to those. Thank you.
Neil, would you introduce yourself, please?
Sure. Hi, everyone. Neil Lacey, CDOT headquarters, Project Development Branch Manager. Thank you all for coming.
Scott, I know you're mid-yawn, but would you please introduce yourself?
Scott Leiker, Region 1 Hydraulics.
Thank you. Allison, would you introduce yourself, please?
Allison Schaub DeRosa, Region 1 Hydraulics. I mostly support the North program.
Great. Thank you. And Stuart, would you introduce yourself, please?
Yeah, Stuart Gardner. I'm out in Grand Junction. I'm the Region 3 Hydraulics Engineer. And I'm prepared to not yawn. I got a big old cup of coffee.
Excellent. Dennis.
I might have to leave for other reasons.
Okay, great. Dennis, would you introduce yourself, please?
My name is Dennis Kress. I'm the Region 2 South Hydraulics Engineer in Pueblo.
Excellent. Thank you. Tyler, could you introduce yourself, please?
Tyler Weldon, Maintenance and Operations. Here to relive some hydraulic calculations and having lots of fun cleaning these ponds off for like 2.5 years with my team. So it's good to see everybody.
Yeah,
exactly.
we were just talking bad about you and all your ponds up on Straight Creek earlier today.
Excellent. Jeremiah, could you introduce yourself, please?
Hi, everybody. Jeremiah Unger. I'm the illicit discharge manager and the permanent water quality field manager for the water quality group here at headquarters.
Thank you. Danny, I see that you just joined us. We are introducing ourselves, just who you are, what you do, what region you're in. Danny, if you're talking, you're on mute. Okay, we will come back. Amy, would you introduce yourself, please?
I'm Amy Tegan, a designer at Respec. I work with Jessie Nolly and help her with the microstation plans that we turn in to you guys. And I help her with a bunch of other stuff too.
Thank you. And Jessie.
Hi, everyone. I'm Jessie Nolly. I'm a project manager at Respec, and I've been working on helping CDOT with its permanent water quality program for a handful of years now. This is just another one of our little task orders.
All right, thank you. It looks like Danny might be having some tech problems, so we will let him join when he is able. And Jessie, I think you were going to go over course content.
Ah, very good. I will start the presentation.
Okay.
Rachel, after I get through this, Rachel's going to go through why we're doing this. But the things that Amy and I are going to go through is what data do you need? Getting that you will see is by far the most challenging part of all of this. We'll go through a general pond volume calculation. We'll go through some examples with that. Then we'll go through a general pond discharge calculation and some examples with that. And then we'll decide. I will simply share with you some of my thoughts on whether to certify a pond. The data, we have been calling this pond volume certification, but really it's a pond certification that it includes both the volume and, does water leave the pond as, was it constructed so that water will leave the pond as it was designed to do? But we'll get into that later. And then we can have some discussion. And frankly, if anybody has anything that they would like to discuss throughout the presentation, please interrupt me. I'll try to ask at the end of each slide if anybody has any thoughts or comments. I would like to ask that you limit those questions and comments to the material being presented. This is just one tiny part of the larger permanent water quality program at CDOT, and I realize that lots of other connections need to be made. How are we going to make sure this, where in the process, if the contractor, is already paid, he's not going to, all of these things don't really have anything to do with what I'm doing, but I know that Rachel will, take those suggestions and questions as part of the larger process. But this is just really intended for this one little piece of the puzzle, and we can hopefully keep it to 2.5 hours if we stay on task. So I will move to Rachel now.
Thank you, Jessie. As Jessie mentioned, originally we had decided to call this the pond volume certification. It actually involves a volume for a pond and an outlet structure, and we can get into more details. But I know that some of you were present when we probably first said, hey, we'd love to have this verification, this check to make sure that CDOT is actually getting what it paid for. So just some background in terms of why this tool is being rolled out. On the regulatory compliance side, we simply have a need to, if we're designing something for a water quality capture volume standard, to make sure that we achieve that. Our financial responsibility is really just ensuring that CDOT gets what it paid for. And then our process standardization, which is something that we're working through with the help of Neil and Al and Jared Esquivel, is just what we're covering in this training when we are comparing an approved design and as-builts that have been created from a survey once that pond has been installed. Do we get a similar result? And whether it's a CDOT or a consulting engineer completing this form, we just want to make sure that everybody understands that there are a couple ways to complete this form. A couple of the other items that happen prior to the completion of the pond certification statement is that number one, the drainage design manual, chapter 16, which has specifically permanent water quality as its topic, has more information about the water quality capture volume standard. So in design, we're looking at something that is reviewed and approved. During construction, there is actually that pond that's installed based on that design. The survey of that pond, once it's installed and prior to the close of the project, is used then to create the as-builts. You're going to use those as-builts and the approved design and compare those. Are there any questions about sort of the 30,000 foot level about the pond certification statement? Okay, Jesse.
All right. So as promised, what data is required before you start digging in? And frankly, you guys, if you get all this data straight off, you can be done with this in 45 minutes, pretty easily. But as I've found in doing these so far, you don't always get what you need. The first thing you need is the construction plans. Those, and the water quality report. The construction plans may or may not contain all the information you need. Sometimes the construction plans show WQCV equals, it defines the water quality capture volume. The contractor doesn't need to know what that is, but sometimes the plans say that, so that makes your job easier. If the construction plans don't have that, then you would look to the water quality report, which may be a subset of the drainage report or maybe a standalone document. What you really need is, what is the water quality capture volume? That'll be an acre footage typically. And then at what elevation is that supposed to occur? And that'll be an elevation. The water quality report will typically contain UD detention spreadsheets. There are other ways to go about it, calculating what, at what elevation the water quality capture volume occurs. But UD detention.xls has made it simple for everybody. So a lot of people use that. The UD detention spreadsheets, if they're in the water quality report, should match the construction plans. So sometimes you might look at the drainage report and say, wow, the water quality capture volume in the drainage report doesn't match what the design plans say. And then you'd want to dig into that a little bit further, but that's a little bit further in this presentation. So the construction plans and water quality report will tell you what the contractor was supposed to achieve. The next thing that you need is the as-built survey in CAD. This could be MicroStation or AutoCAD. I know you guys typically get it in MicroStation. And within that survey, you need closed contours, closed polylines, and you need those above the highest design elevation. Now, technically, this pond volume certification process is only as it regards to water quality. But sometimes if you have a pond that is designed to treat the excess urban runoff volume, the EURV, or even the 100-year volume, that might be something that you would expect to see contours at least to that elevation, or at least one contour above it, so you can do an interpolation of the volume below those designated elevations. Sorry. And we'll get to how to calculate volume in a minute, but if you want to use the magic that is the 3D functionality that's available in AutoCAD and MicroStation, you should ask for break lines at the pond side slopes. That will typically give you more. It will give you more volume, but we don't use those when we do hand calculations in Excel. And then finally, if any of these items are missing, you just need to stop right there. And don't waste your time trying to figure it out, and ask for them to be delivered. Any questions so far?
Yes.
Oh, Al.
I had a question last time, and
Okay.
I just wanted to throw this out for the benefit of everyone else. I believe it was Dennis asked about the EURV. And I told him I didn't think we were required to, we, CDOT as an agency, were required to do that.
Okay, so thank you. And I know you emailed me that question. So the EURV is larger than the water quality capture volume. It stands for
EURV, what's that? Spell it out. Spell out EURV.
Stuart, go ahead.
EURV.
Yes.
Is that a recreational vehicle?
Oh.
European Union recreational vehicle.
That could be. I bet there is one if you Google it.
There we go.
In
That's
this
urban runoff volume.
yes, in this context, it's basically for every storm event. What is the difference between what ran off before humans started paving over the land and what runs off now? So
Okay.
that's a larger volume than the water quality capture volume, and I do talk about that in one of the examples. Sometimes for whatever reason, maybe it's a local agency project and they want to do hydraulic detention in addition to water quality. A lot of times the EURV outlet, if they do go for the EURV outlet will be the same outlet as the water quality outlet. We'll talk about that later, but for the purposes of the MS4 permit, the only thing that we're focused on is the water quality capture volume. Anything else? Okay. So this is just, these two pictures are screenshots of some CAD files that we got, example topo surveys. The upper survey, can you guys see my mouse? Okay, great. So the upper survey, you can almost like see where this is the outlet. These two are 4 bays. You can kind of see this is the overflow. You know, there's lots of closed contours. Even this, I would assume just looking at it that it would be fine. This lower one, you know, we've got this contour. It doesn't really, a lot of the contours don't close. This might be fine because we might be dealing with just a very shallow design depth, and that would be fine. But I just wanted to show kind of the difference between, you know, what a lot of closed contours look like and these are not closed. This one right here is the lowest closed contour, and there's only 1, 2, 3 below it. So that just an example.
Hey, Jesse, real quick, if you were to get one of those,
yeah,
would we need to have the surveyors go back out and reshoot some stuff, or
no? So like this last sentence of this second bullet, this may end up being acceptable if the design volume, if the elevation at which the design volume is supposed to occur is below this contour that I'm pointing at right here.
yes,
Then it's fine.
but if it's not,
if it's above that contour, then, you know, could we assume that this contour is connected through here? Maybe. You know, when you send the surveyor out to get a topo survey, tell him to get the contour above, you know, above that elevation. I mean, it just depends, and we'll get to that too in one of the examples.
Jesse, Scott has a question before you move on.
Yeah, go ahead, Scott.
Yeah, just like the previous screen and this screen. So typically we get the that information from the project manager or the water quality specialist. Who is forwarding this information to either the consultant or to the engineer? Who are we dealing with? Who are we working with? Project manager?
It should be the project manager. Yes, Scott.
Okay.
That's who I've been getting it from so far.
Right.
I think.
Yep.
All right. Anything else before I move on? Great. All right. So that was what you needed for the geometric analysis of the grading, right? The pond volume. This is what is needed to make sure water can leave the pond the way it was intended to leave the pond. An as-built markup of the outlet structure. The outlet structure as built should be a separate viewport in CAD, or it could be a redlined construction plan in PDF. And the data that you get has to answer, how does water leave the pond? So that might be orifices in the orifice plate. How big are they and at what elevation? The overflow weir into the outlet structure. That might be a type C inlet with a top of grate elevation. It might be some other type of structure. And then there may be an overflow weir, like 100-year overflow weir. The important thing is, if there are no PDF markups, if you don't get a markup of the orifice plate that shows different elevations from those in the design drawings, in the construction plans, they weren't surveyed. Because, you know, I could survey the invert of an orifice 5 times and I would get 5 different to the 0.01, you know, values. So that's a near statistical impossibility that if they say, oh, this is as-built, they didn't survey it. So you need to request that it gets surveyed. I know at least one of you, not on this call, but has found out that an orifice plate was installed upside down. So it's worth it to send them back out there and say, you need to get these holes. How big are they? What size are they? What elevation are they at, rather? And as CDOT moves through this process, and they have their contractors, their consultants participate in this process, it may take a few rounds of requests to get the data that you want. But I'm hopeful that enough times of asking it for it, the surveyor will get it. The surveyor will get what you need. This is an example of an outlet structure survey that I got after I said, actually this outlet structure, the first time I got the survey, I didn't get these orifices or the inverts. I got the bolt holes. So the surveyor went out and did a really detailed job of surveying bolt holes. And I had to send him back out to get the actual holes that the water could go through. So this is the level of detail that we're looking for. Yeah. Does anybody have any? And then this top of concrete 5560, you know, that then was the water quality capture volume overflow. Does anybody have any questions on this so far?
Hey, Jesse, I was just going to say, so the as-built survey is typically a plan sheet that has been marked up, red lines.
Yeah.
Right? And if that sheet comes back and there's nothing marked up,
yes,
they probably didn't do an as-built survey.
Right. So this next slide is an example of what I received on another project. And it says as-built in the upper right-hand corner, but there's nothing marked up. So this was a pretty good indication that it wasn't surveyed. For this as-built, moving on to the next one, it's bubbled, and the table is bubbled, but it's unclear, and it says R2. It's unclear, you know, FDC-109. So what I might do on this one is ask for the original design plans to see if, you know, this elevation BB matches. You know, sometimes it's a matter of logistics, trying to mark these things up for as-built. Like if I put a red line through this, where am I going to put the revised elevation? So, you know, sometimes people bubble the whole thing and just change the numbers. So in a case like this, you might look to the original design plans to see, you know, to see what some of these elevations were.
Jesse, I had a question on the last example on the last slide.
This one?
Yeah. So is there just one elevation given there, the centroid of the lowest perforation, and that's it? And then so then just assuming the spacing.
So it has the spacing here. So it says, you know, A is the centroid of the lowest perforation, which would be, you know, centroid of lowest perforation, match elevation A, and the number of rows 3. Now, this is a great example of what I just love, is when people don't bother to draw things to scale. clearly the spacing of the holes is not, well, maybe it is if this whole thing is 13 feet high, but then it's not drawn to scale horizontally. Well, it says not to scale, but like, oh, come on.
Yeah, when that's so badly to scale. I know.
Right. But you go with the numbers, and when you get this, you should be able to go to see in the drainage report that this was the design. But then when you get the as-built survey, you would add 43 inches to this, and then you would add another 43 inches to that, and that would give you where these are supposed to be.
Yeah, okay.
Yeah, so thinking like a contract, like, okay, what is this actually supposed to be, and forgetting that it's horribly out of proportion. That's what I wanted to say. It's fine if a drawing's not scalable, with a scale, but I feel like it should be proportional. But there's no rule for that, so you just have to go with the numbers that are there. So this says, and they should be square, apparently, 3 inches by 3 inches, which these don't look square. But you gotta go with this, and that's, we'll get to comparing that to what's in the drainage report a little bit later. But in any case, they certainly need to, in the ideal situation for something like this, when this is all the table says, is to get something like this back, where they do a sketch of it and they say, okay, I surveyed each one of these rectangles. This is how big they are. This is where they're at. Does that answer your question?
Yeah, thank you.
Okay. Okay, so we will talk more about like going through in the examples, going through what was received. But I'm going to move on now to like the general pond volume calculation, and some different options for that. In your CDOT drainage design manual, 12.72 indicates 3 ways to calculate volume. Average end area is, everybody knows what that is. You would take the average of the elevation, or you would take the average of the area enclosed by contour 1, the area enclosed by contour 2, and you would average over the difference in elevation between those. This is not the most common way to do it, but it's allowed by your drainage design manual. The frustrum of a pyramid equation, that's the one that is more commonly used. And again, you can look these up in your drainage design manual. The final way that 12.72 says that you can calculate is a prosmoidal formula, but it's for perfectly trapezoidal basins, so we're not really gonna get into that. The average end area does result in a higher calculated volume. So as we get into whether we certify these or not, we'll talk more about using that as an option. The frustrum pyramid is the more common way in the metro area. But I did review a pond where in this second equation, the frustrum of a pyramid, this elevation 1 minus elevation 2 was reduced to like 0.01 or 0.1. I think it was 0.01. The more you reduce that elevation, the more the frustrum of a pyramid equation mimics the average end area. So it almost makes it, if you're going to reduce EL1 minus EL2 to 0.01, it kind of defeats the purpose. The spreadsheet I'm going to use in this training does use the frustrum of a pyramid.
Hey, Jesse, real quick. So when you're doing that and those different elevations, those correspond to your contours, right?
Those correspond to the contours, yeah. And then
the contours are only 1 foot. I don't see, I know the example you're talking about where they went to 1/100 of a foot.
Well, and that wasn't so to develop, and I think we may have spoken about this in the last training, and I think it's worth repeating in this one.
Yep.
The way contours are developed is that surveyors go out there and they put their survey rod down and they take a measurement, and then they walk and they take another one, and they walk and they take another one. And the tighter the grid that the surveyor takes a shot, if the surveyor takes a shot every 5 feet, you're going to get a more accurate model than if the surveyor takes a shot every 20 feet. And you won't know the difference. But I'm guessing that your survey manual has frequencies in it for this. And frankly, if you have a fairly uniform side slope, you're not going to get a whole lot more accurate by taking a shot every 5 foot than if you take it every 10 or 15. So surveyors are trained, and you take a shot where the grade changes, or you take it on a grid. The contours that come out of that, the accuracy of the contours that come out of that survey are based, that's dependent on how tight the grid was. But, I feel like for us to question that, you get a survey, it's from a PLS, you got to just go with the given.
Yep.
So that's why we ask them to produce the contours. They're saying that this is what it is. They're saying that this is a fair representation. So we're just going to go with that.
Jesse Stewart has a hand raised.
Stewart, please speak, but you are on mute.
Yeah, I think what concerns me about this is what we should be focusing on is what the designer used and then replicating what they had, because if we're going to come up with a different volume, if we're not using the same methodology they did, then that's a problem.
It's close, and we'll get to that more when we talk about variability and differences.
Well, then probably the first order of the day would be to see if they documented in their drainage report what technique they used, and then I would use whatever technique they used, regardless of what's more accurate, because no matter how close it is, if you're using a different technique, that's bad science.
That's a good academic point.
If they used average end area and then I use the frustrum, then that's not comparing apples to apples, because what we're trying to do is say, well, did we get what we paid for? Well, what we paid for was the average end area.
Right. And yeah, no, I appreciate that difference. I've encountered that, and I'm going to address that later in the training.
Deal.
As well. All right. Does anybody have anything else on this slide? At this point, knowing that I will speak more to it. All right. I don't know how young the youngest person on this training is, and I don't need to know, but a lot of youngsters sure do like to use the magical and automated volume calculations that are provided by applications within AutoCAD and MicroStation, terrain modeling. And they're sure fun and interesting, magical. You can save a little bit of time. You can save a lot of time if you're comparing two irregular surfaces. It's almost mandatory these days that you do, for roadway work or for, an existing grade to a future grade, how much excavation are we going to have? Those are really helpful tools. In the case of looking at pond volume grading and what kind of volume we have below a given elevation, I feel like there's too many pitfalls to generally recommend using that. Some of you may be, Amy Teigen, my drafter, my designer, I trust implicitly to use the magic. But a lot of junior staff, I do not, because they don't realize the shortfalls, the shortcomings of the modeling. For example, if you do not have a closed contour and you are asking it for a a volume below a certain elevation, it will assume vertical side slopes. And you won't even know that it's doing that. So the cons, as I have them listed here, first of all, it's not in your drainage design manual, which that's okay. The second one I just kind of touched on, it might give garbage in, garbage out. We've all heard that. So there's a good potential to give unreliable results there. It's a black box. You can print out the summary, but there's really no way to show the work. And then they're not as usable by as many people. I'm guessing that, for example, Al and Neil and Rachel could follow my spreadsheet, but they're probably not going to be able to open a drawing file and see what I did there. And then the final one is when you're just going below a flat surface, that's a much simpler calculation to do by hand. So I don't want to tell anybody like you can't use, 3D terrain modeling to do this, but I don't personally think it's worth the time. And the pluses aren't worth the potential negatives. Does anybody want to, Amy Teigen?
I have a question.
Yeah, go ahead, Alice.
About I didn't understand what you said about working below a flat surface. What did you mean by that?
The water is like the surface that when we say the pond volume, we mean like the water quality capture volume occurs when water builds up to a certain elevation, and the water is going to be flat at that elevation.
Yeah.
So what is the volume below elevation 5562.46? Like that's easier to do by hand using existing contours than it would be if you had an irregular surface and you're digging.
I gotcha.
Yeah.
Yeah, I gotcha.
That's a much easier calculation to do by hand.
So, I may have missed a little bit of what you're saying, but I think this goes back to, you're talking about the general applicability of using that, but this kind of goes back to what did they do for the design? And if we're going to be using something different.
The differences aren't substantial, Stuart. The differences are pretty minimal, actually. And because I've done these backwards, forwards, and sideways, different ways. And my volumes change by 1 or 2%. So
well, it's not going to mention what you're saying that it's a bad. It's a black box. There's no way to show your work, but.
That's the bottom line of it. But also like, I'm also thinking in terms of, Rachel didn't mention this, but you guys got audited, right? And they said, and I don't know who comes to audit, if it's somebody with an English degree, nothing wrong with an English degree, but
yeah, there is.
Yeah, there is.
and I say that knowing that this is being recorded.
Right. But
that was Stuart Gardner, Region 3.
Okay.
Yep. I stand by.
No, I just think it's a more defensible. Like you can say, like, look, here is all the data, and anybody can follow it.
Sure.
Yeah.
No, I get it, but we're talking about coming in after the fact.
Yeah.
We're talking about after the fact, but comparing, just back to comparing apples to apples is my point.
Yeah. Okay. So what we're ultimately looking for, with a few caveats and exceptions that I'll get into later, is the calculated pond volume at the design water quality capture volume elevation must match the construction plans and the design report within reason. Substantial conformance, or I'll get to substantial conformance, substantial compliance. Sorry. So we can have a reasonable percentages, right? Is it within 5%, 8%? So that's something that we all could look, and I'll get to what will help us determine that later on this slide. For one of the ponds that I looked at for CDOT, somebody said, hey, look, we're allowed, and here it is in quotes, we're allowed variation from the plan elevations of 1 inch. So I actually went in, and all of the contours that were surveyed, I dropped their elevation by 1 inch in an effort to say, did we get what we paid for? And it didn't, it helped like this much. So my goal when I have been doing these certifications for CDOT has been to get us to yes. And, you know, if it's 15%, low on volume, for me personally, I'm not going to say that's a yes. I'm not going to say that was within, you know, substantial conformance, but I'm going to do everything in my power, including using average end area, including using these allowable tolerances to get us there. And that it hasn't so far made a lot of difference. It makes very little difference. But, you know, if you personally want to say, if it's 5.1% short, that's too short. It's got to be within 5% for me. Then those little tips and tricks might help you get to yes. The other thing, so this red text at the top says the design water quality capture volume elevation should be used, and then we calculate the pond volume below that. But what if in the plans, the top of the water quality capture volume is set at the top of Great Inlet for the type C overflow weir, which it often is. Often you have an orifice plate and it backs up water to a certain elevation, and that is where you set the top of your type C inlet, above which the water just rushes out of the pond. What if on your as-built survey, the top of Great elevation on that top C inlet was built 2 inches higher? Well, I would argue that your water quality capture volume now needs to be calculated below that elevation. Does that make sense to everybody? Because water is not going to leak. Water is still going to be backed up and ponded until it hits the top of that grate. So you can look at the design water quality capture volume elevation and calculate the volume below it. But if that's not working out, also check to see if the overflow is maybe a little bit higher, and you might be able to give a little bit more volume to the as-built condition. And then the second aspect of that is, at least on one pond that I did, as I mentioned, the EURV volume was also accommodated for in the pond, and the water quality and the EURV outlet orifice plate were the same thing. So the type C top of, Great elevation was up here. The EURV volume was set there. The water quality capture volume was right here. And there was no way for water to get out of the pond until it reached the EURV volume. That was redundant. The EURV elevation. So maybe you don't get the water quality capture volume at the designated water quality elevation, but maybe by the time you get up to the EURV elevation, you've made up the difference and you have the full EURV volume below that Great elevation. I'll get to that further, but I'm just saying there's things that you can look at to help you get to yes on these. And then, sorry, I think I can highlight text with this, but I can't. I did like a legal term search for substantial compliance. This came from long-term care facilities, but substantial compliance is actually, it says it's used in 42 different statutes. So I'm guessing that it has somewhat of a similar definition. And it is a level of compliance such that any identified deficiencies pose no greater risk than the potential to cause minimal harm. So keep that in mind. And that's where I come in with like the 5%, 8%. Like, come on, hydrology is off by 30% on a very good day. So if you're a little bit short, if you're 50% short, that's not so good. But if you're a little bit short and that sits okay with you, that's okay too. All right, who's got a comment?
Jesse, real quick. So I think that's the way we need to be thinking about this, is that, you know, if it's short, how does that affect water quality, and how does that affect how this facility operates and captures, settles out pollutants?
Yeah.
5%, I think that's a good number to shoot for.
Right.
But
I don't want to dictate it, because
right,
there are these other caveats, like with if a pond is an EURV pond.
Right.
Yeah.
But I mean, we've seen some ponds in the past, and I think this what kind of started all of this, drove a lot of this. These ponds were 50% off.
Yeah.
Because they couldn't dig below some bedrock.
Yeah.
They couldn't get the depth.
Right.
50%. That's not going to work.
Yeah.
That's not good enough.
And that is why we did things like earlier in the scoping. Scott Leiker, I think you were involved in this even. I don't know how many years ago that was. When we talked about, getting borings where you're planning detention ponds, because I think Susie Hagee was like, there was bedrock and we couldn't dig it. And it's like, well, somebody should have looked into that ahead of time. So anyway, I will talk more about this later as we go through the examples too, and give some more real world examples. Okay, another consideration is volume within the trickle channels and the forebays. Like if you're really trying to split hairs.
Jesse, can I stop you right there? Allison has a hand raised.
Yeah, sure, Allison, go ahead. Are you on mute?
Sorry, I'm double muted. It takes me a second to. If we have questions during this, the first few times, I guess this is a question for Al, is Respect going to be a consultant on call if we have questions, like to talk through this process, or we get stuck on something and we're trying to figure out a solution?
I don't think so. Maybe. I don't know. We're trying to get Respect back on board here for the next year, but I'm not sure if that's going to happen or not. So
it might be good. I just feel like it's going to be a learning process.
No, I understand.
Even because it probably won't be a lot of time.
Will be questions, and you can try me at first. But I think the big question here that Jesse's pointing out is there will be a tolerance here. It won't be exact, right?
And it's all potentially seeming very difficult, but if you have all the information you need, it is really straightforward. And if they did a good job, like that's the thing. Like I've spent a significant amount of time trying to like get to yes. Like I said, like, oh, where was the outlets? But really probably 75% of the ponds that I've looked at, and I mean, I think there's only 8, but I think only 2 of them didn't meet the volume requirement right off the top of the bat, right off the bat, not the top of the bat, mixing metaphors. So, and I think as CDOT proceeds through this, also it will become apparent to the contractor, dude, if you're going to miss, you need to miss high. Like, don't be short on this. I did want to look at one other consideration, that sometimes we have, I think more and more, we're going to be having trickle channels that are like 6 inches deep. So, you can see in this survey on the left, these portions of the contour. This is obviously where the elevation is rising along that 6 inch deep trickle channel. So this one probably accounts for the trickle channel. This one maybe does a little bit, but this shows, this shows no surveyed trickle channel here. So if you wanted to try to somehow add volume by doing that, that's an option. I mean, that's really going above and beyond, but I just wanted to touch on it. Okay. Here was another, and this goes back to, again, what if you're getting everything you need. Sometimes the design documents may have to be reviewed to understand the intent of the construction plans. Sometimes the water quality capture volume or its associated elevation may not be in the plans. I said that kind of at the beginning. What if the reviewer notes that the design documents, the UD detention or water quality report do not match the construction plans? This process that we're talking about, we have gone over this internally a few times. We are not questioning the design here. This is not about questioning the validity of the design, but what is presented in the design should match what's in the construction plans, which should then match the as-built. All within reason, of course. So feel free to ask the CDOT employee who was in charge of reviewing the design documents as to which documents are correct. Sometimes it's just a matter of the consultant forgot to switch out a page in Appendix Z, and oh gosh, we redid everything, but we didn't switch it out in the report. My bad. And that's more often than not. These drainage reports are like 300 pages long, so stuff like that can get overlooked. So I would just, if you come across something where the design doesn't match the construction drawings, you might just ask about it. It might just be a simple ask. Okay. Does anybody have any questions? Yeah, go ahead, Rachel.
Questions, yes, and then I'd like us to take a break before you get into the first example.
Okay. Any questions? I think it'll be clear too as we get into the examples.
Great. Okay, let's take an 8-minute break. We'll be back at 2:05.
Okay, thank you.
Thanks, everybody.
Rachel? Hey, Rachel.
Rachel, you're on mute.
Go ahead.
Can I stop this and start it? I don't know. I've never done that before.
I think it'll make 2 different recordings, but you can certainly try it, and then we can stitch them together if needed.
I'll hold on to it. It's only, what, probably 7 minutes, 6 or 7 minutes. I'll let it run.
Okay, sounds good.
We'll have a nice little pause there.
Amy, are you ready with 1082 South?
Yes, I am.
Okay. I'm gonna run to powder my nose.
All right. That is a well-deserved break. And now we get into the fun stuff. Could everyone who's on the call just raise their hand and let me know that you're back? I want to make sure that on the screen. Don't be.
That's my brilliant sense of humor.
Scott's back, Tyler's back, Amy's back, Neil's back, Jeremiah's back, Stuart's back. Okay, it looks like we have everybody and okay, Dennis will rejoin us and Danny is back too. Okay, go ahead and put your hands down and take it away, Jesse.
All right, I'm here. Okay, so we're gonna look at one of the ponds that I reviewed for CDOT. And as I stated at the beginning of this, we are, the first thing you need to know to figure out if it was built to plan is figuring out what the plan is. So for each pond that you review, you need to determine the design water quality capture volume and the associated design water quality capture volume elevation, the elevation at which or below which the water quality capture volume will be stored. So I am going to show you the as-builts that I received. The red text is mine, not theirs, and you will note that nothing has been crossed off here. So I'm not entirely sure at this point what the as-built was, but that's not the first step. The first step is determining what the design was. And we've got this table down here.
You're sharing.
I'm not sharing?
Nope.
Oh my goodness. Okay, let me try again. So I get confused about whether I need to present a window. I think I will present my entire screen. All right. Are we seeing an as-built?
There you go.
Okay. Are we seeing PowerPoint now? Okay. My apologies for that. I will go back to the as-built. So this is the as-built plan I received. And because there's more than one pond involved here, you can see they've got it in a table, which is typically a nice way to do it. And we zoom in here. Hope nobody gets seasick easily. We zoom in here and we see elevation B is the EURV / water quality capture volume. Well, and this says HEURV. So as I said before, EURV is not always included, and the water quality capture volume is less than that, typically, is less than that. So in looking at this table, and there's the overflow, it's showing that at this elevation, it's going to start spilling over into the outlet structure. So the water quality capture volume is not actually in here. And the water quality capture volume elevation is not in here either. And we can look at the orifice plate detail on the next sheet to see if the low orifice is at this design elevation, just to confirm it. 40.72 is the top of the micro pool, and that's typically where you put your first orifice when you just. And as a sidebar, going through the Mile High Flood District's Volume 3 on how to design an outlet structure will be really, really informative if that hasn't been part of your practice as an engineer thus far, in letting you know what typically is done and how to go about reviewing plans. I know everybody kind of does different stuff in their careers, but Volume 3 is a really good. They have a whole section on outlet structures and water quality capture volume, extended detention basins. That's a good thing to review. But in any case, this says the micropool, the centroid of the lowest orifice is 40.72. We go to the next page. That's consistent at least. Centroid of lowest perforation, 40.72. But again, there's no water quality capture volume. So in that case, open plans and note neither is noted, only the EURV elevation. All right, so now we're going to go to the drainage report to see if it's in there. And this is what I was referring to before, like sometimes not all the information you need is on the plans. So this is the 5 pages of the drainage report that I excerpted for this presentation. I think there was probably 150 pages or something that I had to dig through to find it. But the good news is it's searchable in PDF. So you can type in the word retention basin and get to this. So here are some values that we have. It says the water quality capture volume is 1.542 acre feet, and the EURV is 4.048 acre feet. The zone 1, which if we go up to this schematic, you can see water quality capture volume. This is almost exactly what the outlet structure looks like, right? Here's the EURV. It's where the overtopping occurs. The water quality capture volume is zone 1. Here's your permanent pool, your micro pool that we talked about. So looking at this, zone 1 is 1.542. That matches here. The elevation at which zone 1 occurs is on, this says, I don't know why this is hidden, but it says zone 1, water quality capture volume. Here's that 1.542 acre feet again, and a stage of 4.37. So that is above the lowest orifice centroid elevation. So we have the 1.542 acre feet at a zone 1 stage of 4.37. The EURV, I won't show, it's in there again if you guys want to go through this. That's 2.506. That was a stage of 6.12. So again, the zones begin at the top of the micro pool. That's the permanent pool elevation of 40.72 that was in the plans. The as-built condition is unknown, but what was the design? The design water quality capture volume is that the centroid of the lowest orifice, or the top of the micropool, this is the permanent pool, 40.72 plus the zone 1 stage of 4.37. So we end up with a design water quality capture volume elevation of 45.09 and a design EURV elevation of 46.84. Why bother with the EURV? I think I mentioned that a little bit before, that maybe if your water quality capture volume is a little short, but maybe they make up for it before the water starts spilling out. That might be why you would want to consider the EURV. So 46.84 is our design EURV elevation, and we can go back to our as-built and we could see, is elevation B 46.84. So that kind of confirms that the design plans are meshing with the water quality report. And now we should have some good, we should have a good concept of, we've defined our grading goals, right? So now we can evaluate the as-built contours.
Hey, Jesse, question.
Yes.
Go back to that plan sheet. Shouldn't they have put the water quality capture volume on that? Isn't that kind of
I mean,
standard info?
I don't know where I don't know where all these rules about what goes on the plans are, but yeah, that'd be nice.
Okay. Was this from our CDOT project, or?
Yeah. 1082 is along 470.
That's what I thought. Okay.
So the reason it wasn't on here is because your other ponds along C470 that don't have EURV do have the water quality capture volume.
Oh, okay. Okay.
So this sheet just, it wasn't, the table was not set up for, all they had to do was add another column.
Right.
And say EURV not applicable on the other ponds.
Yep.
But, whatever. I mean, that's fine. It was, it was nice. It all matched up. So All right. So, oh gosh. So now we have our goals, right? We have a water quality capture line 45.09, and we have or elevation of 45.09 and a volume of 1.542. So
I have a question. So what if it doesn't match up? And I know we're not checking the design, but what do we do?
Well, that's when I mentioned earlier about, look, it might just be that they didn't put the most updated UD detention spreadsheet in. They might not have updated the text of their report, and that's
what if they just screw it up?
Well, that's when you call the person who sent you these files and say, hey, these don't match. And that should be the project manager for the design portion of the project. And then they will get back, that person, he or she will get back with the consultant that did the design and say, why don't the design plans match your drainage report? And then you just go from there. But to hold them accountable for it, it's fine. Like, if it doesn't match, it doesn't match. Now, if it's off by like 200ths, forget about it, But typically that's at what point I would say, why doesn't this match? And I actually did on one of these, the naming of the pond was, I was like, which pond am I looking at? Is it? And they said, oh, we're so sorry. That was from a previous submittal. Here's the right spreadsheet. Here's the right PDF. And we went from there. So if it doesn't match, that most of the time it's going to match. If it doesn't match, that's when you raise your hand and say, this doesn't match. Give me the right information. Give me information that matches. Yeah. So I don't know. Was there anything else on this earlier slide? And again, there's all kinds of guidance on the Mile High Flood District on there. I've kind of accepted the UD detention spreadsheet. I previously enjoyed doing my own spreadsheets, my own orifice and weir equations, but nobody wants to hear what I have to say anymore, so I have to use the UD detention spreadsheet to prove that my design is good. So I've become more accustomed to it. I think they have like a YouTube video on how to use it. Yeah, the information is there because I know I'm going through it pretty quickly here. So complete the spreadsheet by starting with the as-built elevation of the lowest orifice and the area of the micropool at this elevation, if it's known. If the area is unknown, use 0. So I'm going to share this spreadsheet. This, I believe, is it's in the documents that Al shared for this class. And this is, so this 40.72, can you guys see the spreadsheet? Okay, good. The 40.72, if you recall, is we don't yet have the as-built. I don't know that I ever got the as-built for this, but assuming we get the as-built and it's the centroid of the lowest orifice is 40.72. That's where you start with the spreadsheet. You give it a surface area of 0, and then for every contour you go up, you put in the area, and I am going to...
Jesse, Jeremiah has a question.
Thank you. Please speak.
So Jesse, in your example of 40.72 being the top of the micropool elevation, is that taking into account the initial surcharge volume?
I knew you were going to ask me that.
Jeremiah's screwing up.
It looks like the initial surcharge volume may. I don't know. I think that wherever the centroid of the orifice of the lowest orifice is, that's where you need to start because that's how water gets out.
So looking at this plan that you have here in front of us, Jesse, is it safe to assume that the initial surcharge volume wasn't built into the volume of the micropool?
let's see, maybe elevation J is above elevation A. Oh, look at that, Jeremiah. Elevation J is what, 9 inches above elevation A? So it doesn't show it, but this is again a lovely, I mean, this is where drawing one drawing and then using different variables. It looks like this elevation is much higher than this.
Okay.
So, but that, Jeremiah, would not be something for this aspect of the project. It would be for the design engineer to catch, right?
Right, and I guess I was just asking the like going from that water surface elevation for the top of the micropool.
I think the surcharge does go above the lowest orifice, right?
It should, yeah.
Yeah, and in this case, it appears to, because this elevation J is about 9 inches higher, maybe. Yeah, it's about 9 inches higher.
Okay, thank you for going through that. Thank you.
Yeah, sure. So, Amy, is this where I have you do? Yes, it is. So, just as Amy's just going to give a quick tutorial on, so what this spreadsheet is, I'm going to explain the spreadsheet. For each elevation, these, this 40.72 is the centroid of the lowest orifice. All of these other elevations in yellow, they correspond with contours, and these surface areas correspond with the area bounded by the contour. And so you go through the CAD file. I'm going to stop sharing, Amy. And you can share your screen now. And Amy's going to do a little tutorial. This may be redundant for many of you, but I think and she also included a written tutorial in the documentation associated with the class. So she's going to kind of walk through. Oh, LBNF.
So this is the document that Jesse was talking about. In here, it tells you like where I'm going to get all of these tools in the MicroStation file if you don't know how to do them. So that's included. We won't go over that right now, but if you have questions, that's how you'll get the answers there. And then, so what Jesse was talking about is so to get the area, you open the measure area command, and then you want to change this method to element. And then when you select the element, it tells you right here, the area in square feet. And it also tells you down here, the area in square feet. And then that is the area that you are entering in right here. So that is telling you that it's contour 41. And if you don't know, you can get that information from here. From the
is it 41, Amy? I think it's another. I think it's 43.
Oh yeah, 41 is over here. And then that's where you get the areas right here to put in.
Where does it show the elevation of the item you clicked on?
So that's in a different command. So you have to go to the select button, and then you have to click it right here. So this one is telling you that this one that I just selected is 5642 elevation, and this is in the information, the element information button.
And then go to
the area one only tells you the area. It does not tell you the elevation.
So at elevation 42, so now we're looking at both screens. So at elevation 5642, we have an area of 1704 about.
Yep. And so that's where you would put in 1704 right here.
Right.
And then once you already have this going, you can just click on the next one. And I think that it should just keep taking you.
Yeah, 163.
And then you take 163 in here. And then you fill it out all the way to the bottom. And so you just get your areas for this column.
So this is just for the yellow, guys, and we'll talk about the orange and the blue in a second.
Dennis, go ahead.
I noticed earlier in the conversation we were championing the frustrum method of calculation volume and the average end area, but now we're doing average plan view volume
No, that's
calculation.
the frustrum of the pyramid equation is what's in column D, and you use the areas. The input to that equation is the areas at each elevation.
So like everything in gray is calculating automatically.
So if you look at column cell D10, the letters A and B are the variables in column B 12 and 13. So like when you move from 12 to 13, the cumulative volume between 12 or the volume added between 41 and 42 is 798 cubic feet. And the H value is in column C. And that's the difference in elevation between rows 12 and 13, or elevations 41 and 42. So you can change the formula used in column D to A plus B divided by 2 times H. And that would be the average end area.
When you say D, you mean 4.
What did I say?
Correct. Jesse, there are just column D actually has the number 4 under the table itself.
Okay, column 4. Those are just numbers. I don't know. I don't know what row 9 is for, actually. Oh, I think there's notes down below. That's it. Yes, there's notes. Note number 4 says this is how to calculate volume between contours. And number 3 says this is the adjacent cell column 1 minus the previous cell column 1. Yeah. So those are just notes, but you have the first column is the elevation of the contour. The second column is the surface area that is bounded by that contour. The third column is the difference in elevation between that contour and the previous one. And the next column is the volume between those 2 contours. And then the fifth column, column E or column 5, is cumulative volume. But this spreadsheet is in the materials as well, and you can look through the formulas. But you'll see that the formulas that we have in there, match cell D11, which is just text. It's just a text string, and it's what matches your drainage design manual. Does anybody have any other questions on this, or questions for Amy about MicroStation? And I'm going to talk about the different colored cells. There's also a legend at the top of that spreadsheet that talks about what the different colors mean, but I'll go over that in a second. Does everybody know how to use MicroStation to do that? Or maybe I should say, does anybody not know how to use MicroStation to do that?
I can't use MicroStation at all.
But Stuart, I bet you have staff that do.
Well, that was your question you asked.
I know.
I got to be honest, I haven't been in MicroStation in probably 15 or 16 years.
Do you get in CAD at all?
No.
Okay.
Not
yeah.
at all.
You guys are like me. Our pay grades are too high for this crap anymore.
Well, no, back 20 years ago, I was a really good CAD jockey.
Me too.
And,
Me too.
We got drug kicking and screaming into MicroStation. I took a week-long class, and nothing, not as if So,
Hey, I knew Geopack 20 years ago.
yeah, I heard of Geopack. That was it. But
Yeah.
no,
Okay.
they took AutoCAD away, and yeah, I'm out.
All right. I actually started using MicroStation and Geopack. All right, Amy, I'll take it back over. Thank you for that. Screen one. Are you guys looking at the spreadsheet now?
Yes.
Yes. Okay. So I wanted to, let me go back to the PowerPoint. So we decided when we were trying to figure out what the elevation, the water quality capture volume was at, that we were shooting for elevation 45.09. So we did these contours. I'm just going to talk about how this spreadsheet was created. We entered in all the contour elevations here just straight away. And then we inserted rows here and here and here to reflect so we could insert the various design elevations. And this, you'll notice these yellow cells. If you look up at the formula bar, these are all just values that were inserted, the yellows, but the blue is a fun interpolation between 45 and 46 to get the volume that occurs at 45.09. So we get, what would the approximate area be at 45.09? And that is a direct interpolation, and that's okay. But we end up over here as what is our cumulative volume is 1.598. And if you recall, our design was 1.542. So we're there. We did it. They did it. It's all good, provided we get the outlet as-built structure, but we'll go there in a minute. I also went ahead and put in the EURV elevation just for fun, and we got a cumulative volume there of 4.099, which beat our EURV design volume. Now, Al, in a previous training, said, but what if we end up with way too much volume stored beneath the overflow weir? Like, won't we be running potentially into, water rights issues? And I would answer to that, you would have to be way over to impact. I think that the water rights spreadsheet is something like 120 hours for the 100-year event, maybe. So, and these are designed to drain over 40. At least the water quality capture volume is designed to drain over 40. So the odds of a contractor being so ambitious as to dig such a large hole, so much larger than planned, that it would impact water rights is going to be a stretch. Certainly 4.099 versus 4.048 is not anywhere near. And of the 8 ponds that I've looked at so far, I would say you would have to be over by like 20% maybe to even look at it. Yeah, so that's not really an issue. Note that if the design overflow weir and at which the water quality capture volume is set has a higher as-built elevation, the water quality capture elevation may be raised to that level as well. I spoke a little bit about that previously. That's not the case with this. We actually don't know where the as-built volume is because I don't have that. That's just something, and I think we're going to look at that in the next example. Does anybody have any questions about what's going on here at this point? That's awesome. Okay. this is basically just what Amy went through, this slide. So I'm going to move on to the next one. This is another.
Hey, Jesse.
Oh,
sorry.
yeah.
Sorry, real quick. So you would certify this pond?
Oh, for sure.
Okay.
Well, actually, I would request that they send me a real as-built of the structure and not this.
So that red is not theirs. That's you?
That's me.
Okay. Okay.
Yeah.
They had no markups on this.
They had no markups on this.
Well, actually, what are the little bubbles?
Well, the bubbles aren't. Well, so this is this R2, which I don't know what that means. This doesn't say, this is probably somebody's initials, but it doesn't say AB. So this is the one where I would ask them, like, or I would go to the original design. First of all, they didn't modify these. There's no bubble around this.
Okay. Okay.
And, you know, this overflow weir elevation, you know, that's great, 46.84. But yeah, I would ask to get a survey that looks like this. Top of concrete, where are the holes? How big are they? Okay.
Yeah.
All right, I'm going to get rid of that, and I'm going to go on to the next example is pond WQ56L/3056L. And this was the one that I said the ponds were named differently, and I couldn't tell what was going on, so I had to ask about it. But again, first thing you do is determine what is the design water quality capture volume and the elevation at which it's supposed to occur. So are you guys seeing these as-builts? Okay. So this has nothing to do with the pond, but I wanted to show you, like, they know what an as-built is. You mark it out and you put a new elevation. So if that's on one sheet, but it's not on the other sheets, then they just didn't do it. So this one, though, if we zoom in a little, oh my gosh, look at that. Water quality capture volume, 0.137. Water quality, water surface elevation, 53.73. Done. That's great. Now, I did go ahead and look through the report just to confirm that. Technically, that's not something you would have to do. There it says the drain time is 40 hours. That matches the water quality plan sheet. It says 40 hours right here. Just went through, and this is what was confusing, I think. Maybe not. Hang on just a second. 53.73 is, oh, this is the one that, so this one got confusing because I was reading this. The water quality capture volume computed for the impervious tributary area is 0.137, and that matches here. And then it says the volume available at the top of the structure is 0.599. And I was like, well, why? What's going on there? It says it allows for future increases in water quality capture volume. So that told me that this pond was built not only to provide water quality treatment required for the current construction project, but it was also built to treat water quality from runoff from future construction, which is a great thing to do. But that was a little bit confusing at first, I think, in some of the documentation I was looking in. But all of this ended up panning out for the existing condition. And then I looked in here for these design sheets. Here again is uddetention.com. We've got the water quality capture volume of 0.137. That matches what the plans say. If we go on to the next sheet, that occurs at a stage of 1.79. Let me go to my PowerPoint now. Well, and this I think was an example. And one of the places it said 1.79 and one said 1.73. But the lowest orifice centroid was supposed to be at 52. So, you know, the relationship of the stage in UD detention doesn't really work with elevations at all. It just talks about stages. So, you know, to look at these stages on both, I think this one said 1.79 and sorry. No. Maybe yeah. If this says it's getting, I don't know where the stage is on this. Maybe it's not on this sheet at all. My apologies. Sometimes it takes a little bit of back and forth. In any case, we know what we're looking for. 1.37 acre feet at elevation 53.73. 53.73. And then I wanted to show you the next page of plans notes a different ultimate condition and a different ultimate condition, and the ultimate water quality capture volume is not actually in this table. Yeah, so here it says, it just calls it proposed water quality capture volume 53.73. And then here's the ultimate, which is where the grate elevation is set. So this is kind of the same concept as the EURV, where, you know, there's a little room to be flexible in here. As long as the ultimate water quality capture volume is underneath this elevation of 55.6, it might be okay for this to wobble a little bit, to be a little bit, you know, to not quite get the elevation. Does everybody kind of get that? Like, you know, this says what proposed water quality capture volume at 53.73. Well, what if it doesn't occur until 53.9? Well, as long as you have the ultimate water quality capture volume under this 55.6 elevation, it's got the same outlet. So it still will, you know, function in substantial conformance. So that's just another example of that. And here's the water quality, the centroid at 52. All right. And then why bother with the ultimate condition? That was the same thing as why bother with the EURV. So then we went right into looking, you know, evaluating the contours that were out there. And this is an example. The white contours are the design contours. And the red and blue contours are what the surveyor gave us. And let me get to, I will get to the spreadsheet in a second, but spoiler alert, they didn't meet their volume requirements. And so this was kind of, well, maybe I should go through the spreadsheet really quickly first. So this one, this pond that we're looking at right now is this as-built that I got. So that was great. I got all these inverts. I got, you know, orifice holes are 1 inch in diameter. Here's the top of concrete. Plans say 55.6. This is the ultimate condition water quality capture volume elevation. The surveyor says it's dead on. You know, I'm not going to argue with that because this is a separate PDF he sent me. These are inverts, not centroids, but that's easily calculatable enough when it tells me it's 1 inch in diameter. The centroid of the design for the lowest orifice was 52, and the as-built centroid was 52.05. That's It's about as close as you're going to get, but I did want to make the point that to cross all the T's and dot all the I's, I did use 52.05 as the starting elevation and not the design elevation of 52. And then I went through and I entered, all the as-built contour areas, and I stuck in the design water quality capture volume, and I got a interim condition water quality capture volume of only 0.079. So that was 42% short. So that's pretty short. But then, like I was saying, I thought, well, maybe they'll pick that up by the time the elevation gets to the top of the outlet structure, which is 55.6. And that volume was 0.523 and the design was 0.599. So that was only 13% short, but still short. So before I caused a big kerfuffle and said I wasn't going to certify this, you'll notice that in this cell, I did use the frustrum of the pyramid equation. The CDOT drainage design manual allows me to use average end area. So this tab that says AEE, that means average end area. You'll see we go from minus 13%. Well, now that's interesting. That seems, we got a new, I'm sorry, you guys. We got a new survey at some point in there. So the new survey was actually 18% short. We got 0.490 at the ultimate, at the spillover elevation. And when I went to use average end area to try and reduce that, I went to 17%. So Stuart, that's kind of one of those things that I was talking about, and Dennis, maybe you said something too about it. It's not going to make a huge difference, but it might make your life easier in some way. But even going from frustrum to average end area, I only picked up a percentage.
Jessica, I just wanted to make one other, just a comment, and it's a comment along Stuart's point. You're making this into a frustrum, a pyramid, an upside down pyramid. It's a very uniform shape. If you just take the average area times the difference in elevation, you get a much more accurate volume calculation. When you artificially give it a regular shape when it's an irregular pond, you just add another area where you're going to disagree.
I think that there's some academics that would argue with you on whether average end area is more accurate. I read quite a few posts about, I'm not a mathematician. You can do it, and you can do whatever you want. I'm not here to tell you which one to use. Your drainage design manual says you can use either one. You can use either one.
But I'm not talking about end area. I'm talking about plan view area.
Well, end area, the end area method is if the area plan view area is its end area turned 90 degrees into the air. It's the same formula. It's the area of elevation 1, the area of elevation 2. What's the average of those times the height difference? That's the same as taking a cross section going from here to here.
Maybe I should have clarified that in my experience, end area usually is associated with a cross section.
Yeah. So this is a cross section taken horizontally. It's not.
Which I have never seen used in the industry.
Yeah, well, it's for a cross section, really. There probably should be a different word, but yeah, the idea is it's just the average area.
Yeah, it's average. So average area. We could call it average planar area, if you'd like.
Which is what I did. I called it average plan area.
Yeah, and then, it's the same formula though.
In my experience over the 4 decades I've been doing this, end area is always cross-sectional embankment, fill, or excavation.
Yeah. In the pond world, In the pond world, we use average end area for planar area as well. You can call it.
Some pond worlds are different than others. My pond world never, and I was confused with the terminology. I'll stand corrected.
So this is what your drainage design manual, Albert, I guess, wrote that, calls it average end area too. So sorry for the confusion. I could see how that would be confusing if you're thinking about, what are you doing? Cutting a section through the pond. And then how does that have to do with area? But yeah, it's average planar area. But it's the same formula, but yeah, maybe we could communicate that differently. Tell Albert to change that. In any case, we don't get a huge, we go from 18% short to 17% short by changing our formula. A plus B divided by 2 times H. So then what I did, and I mentioned this a little bit earlier, this was all things I was doing to try to get to yes, was you'll notice these contours over here, 54, 54.5, 55. When someone brought up, hey, they're allowed to be off by 1 inch in their grading. So I used the same areas that I had previously, but then I dropped all of the elevations by 1/10 of a foot because that was suggested to me. And that actually gave me more of a difference. Now I'm only 12% short. But I'm still 12% short on the ultimate condition and 39% short on the interim condition, which the interim condition really, I have no issue with that. If the ultimate's still 12% short, that's a problem. So then what I did was, and this goes back to your thought, Stuart, on, well, how did they calculate volume in the design? And so then I went into I went in and I measured all the areas of these white contours, which I was sent the design by Muller. And so I measured the areas of the white contours and I put them in my spreadsheet, and I still ended up with 4% short. So I thought, huh. So then I used average end area, and I got really, really, really close, 2%. So somebody asked in the previous training, hey, maybe we should over-design the ponds a little bit, make them a little bit bigger than they need to be, just to give the contractor some cushion. And I have 2 thoughts on that. Sure, why not? You're just going to pay a little bit more for it. But my second thought is, of the 8 ponds I've reviewed, 6 of them have been fine. So contractors can do this. And I would like to kind of touch on how the contractor messed up on this one. And I mean, but I think that's a point worth repeating. The contractor can build this to design, and if they would have built it to the design, it would have been fine. So after going through all that effort of trying to get to yes and still being 13% short, I kind of raised my hand and said, this isn't going to meet, the design. And they insisted that they constructed it correctly. And that's when I got I overlaid these 2, and yeah, these, this is very close. This is very close. These look close. So what we did was, but this one is a little bit off, and this one is way off. Like, this red contour should be out here. So what we did to explain to the contractor where he may have come up short is we cut sections along these lines that you see. And I'm going to show you that in the next slide. So this was the as-built survey, and this was the design. And this was the as-built survey, and this was the design. And these 2 are the ones in the corner. And then this one is the one going right down the center line of the pond. And you can see that they do match up as they get farther away from the outlet structure. But what the contractor did was, coming out of the outlet structure, he increased the grade really, really quickly and then flattened out instead of following the contours. And that ended up being enough to be too much for me to be comfortable with at 13%. And you can see that, you know, if you look closely at the contours, you can see that they hug in a little bit in these corners. And so that's what made the difference.
Do you think some of these take sediment during construction? So it's probably a good idea to survey them when they're freshly ready?
Yep. I think they do, but I don't think they take, I don't think they take 168 yards of it.
Hey, Tyler, I think that's a really good point, because I think one of the Region 4 ponds, if I'm not mistaken, Jesse, they let it sit for several months, right?
But again, I don't think they take 100. So
No,
but that's a fair point. Like, and also, you want to get this done. You want to get this. If the contractor needs to go back out there, you don't want to wait till he's demobed and everything and been like, uh-oh, what are we going to do now? So I think that's part of like the process that, you know, CDOT is developing for a timing and a, you know, everything else to get this going.
I have a question about this example.
Mm-hmm.
So the interim versus the ultimate, they were planning on growing this pond over time to...
No, not planning on growing the pond, planning on accepting additional
development for the pond.
Yes. So
it really needs to meet the interim, right? It can't just meet the ultimate.
I don't think so, because the water quality outlet, the plate, and let me go to the plan view here. If the water, let's say, I don't remember what the water quality capture volume was. Let's say it was 1.5 acre feet. If that occurs up here, it's relatively going to drain in the same amount. It'll be a little bit different, but it's not going to be drastically different. Again, I want to get to yes. The important thing is, are we going to store? Because whatever happens before full build out, it'll get a little higher, it'll be a little lower. It's still going through the same orifice plate. It's not leaving the pond too soon. So you want to get your water quality treatment. It's not leaving the pond too soon. But when they pave over another couple lanes, and now you have runoff from more impervious area coming into the pond, and now, if you don't have enough volume, now it's going to start spilling over too soon. That's when your problem is going to happen. And that's the same with the EURV concept. If the water quality capture volume is here, but the orifice plate, you know, it's still this orifice plate, so the water gets a little bit deeper. It's still not going anywhere. That's less of an issue. But what you don't want is for water to be leaving the pond too soon.
And maybe I'm not still following, but if we're approving this pond for the interim and also the ultimate condition when they're doing more pervious area, then I don't want it to be out of volume and spilling over, like you're saying, as soon as they add another lane. So, I'm concerned. I guess from what I'm understanding, I wouldn't want it just to match 13% off on the ultimate or 5% off on the ultimate. I would want it to be 5 or 7% off on the interim condition.
If you're going to stamp it, that's perfectly fine for you to say. That's if it's about your level of comfort, and if you want their interim elevation to not be higher than this, then that's what the plan said. So they need to build it like that.
Yeah, and so I'm trying to understand why you're not concerned on that.
Because the way that water quality is treated in an extended detention basin is through detention time. And if anything, the detention time, if the water gets a little bit higher, like I said, let's say it's 1.5 acre feet is the interim design water quality capture volume. If that ends up being right about here, it's still not leaving the pond quickly. It's still having to go through this orifice plate no matter what. So it's not leaving the pond any quicker, and therefore it is being treated for water quality. But if we add a bunch of paved area, runoff from a bunch of paved area that also has to be treated, and that ends up here, now that's not going to be treated. So if the ultimate, like let's say the ultimate water quality capture volume was 2 acre feet, if that was still below this overflow spillway, then I'd be okay with that.
Yeah, okay, I get that. But it's probably not going to be with these percentages off.
No, it'll be 13% short, like on the best day, because I did the most beneficial calculation. I tried every which way but loose, right? To get to within my comfort zone, and 13% just isn't there.
So how much time did you spend on this one with the different calculation methods, and then pulling cross sections and conversations with them to try to resolve it?
A lot. I'm doing all this upfront work for you guys. So by the time it's your turn, everybody's going to know what to give you. Yeah.
That we have enough of the same contractors that you think.
Yeah. That's, I mean, so like I think I said at the beginning of this presentation, the hardest part of this is getting the information that you need. And also, again, 6 out of my 8 ponds passed with flying colors. And so there was really it was like an hour or 2, maybe. It was this one where it didn't right off the bat make it. And so then I spent a lot of time trying to, what else can I justify? What else can I justify? And so this one took a lot longer. I mean, this was, probably pushing a day between all the coordination and back and forth, and then cutting cross sections to say, no, you are wrong. Look at this cross section. And then once we sent them the cross sections, I haven't heard anything. So
I have talked to them, Jesse.
Oh, okay.
And they are fixing. It's my understanding, talking to the Region 4 hydraulic engineer, they are fixing this.
Okay.
I think they've admitted that it was wrong. It is wrong. And they are making the corrections.
Yeah. And this kind of thing happens. And I think I just would probably put money that this same contractor, next time he has to grade out a pond, he's going to make sure he gets it, So anyway.
Then another follow-up question. Do we have concerns when they have to get this additional volume? Will they just excavate an area, not in the center of the pond, not at the trickle channel? So it might be weird ponding somewhere else.
Well, I would hope that.
A concern?
Yeah, I mean, I would hope that when they go out there, they're getting it back here where they should. That would be part of somebody of the job of whoever the project manager is for construction, to make sure the thing. And frankly, you could tell them, you better make sure it still drains, because I'm going to fail it again if you we don't want a big hole in the middle that doesn't drain. So yeah. That has been part of my conversations, though. I did the other pond that was short. I made suggestions on where they could pick up additional volume. So it's just a collaboration, I think, at that point. Rachel, is your hand up?
No, it's
not. That was me. That's me. Sorry, Scott.
Oh.
Just a question. Did you go back and look at the construction plans? Because I have seen some construction plans, and I'm like, there's no data points. You didn't give the contractor enough information here to build this properly.
Well, So here's the plans, and there's a lot of points in there.
Okay.
I will say, and okay, first of all, I agree with you, Scott, about that. Secondly, every project I've had in the past 5 years, I have the contractor asking me for my CAD files because apparently they just Caterpillar now makes a machine where you just like put a thumb drive in and then it drives itself.
Huh. Okay. No, I just curious. I was wondering, okay, so was this a contractor issue or a design issue where they didn't give them enough information? So it looks like it's a contractor issue.
Yeah.
Okay, thanks.
Yeah, I am a stickler for, control, grading control, like how I'm a contractor. Where is 0 + 0 0? You're not like, how am I supposed to find that? But it seems like anymore they just ask for a where are your surfaces? And they give it to the excavator and they magically just run themselves. No excuse. I still think if I'm going to stamp drawings, I can get there, on my own, but, okay, we've got half an hour. So, are we almost done? Oh, almost. Okay. So takeaways so far are you need a detailed as-built survey of the outlet. And that will also help you regarding volume. That will help you define what elevation, what is the elevation of the bottom of my water quality capture volume and what is the elevation of the top of my water quality capture volume. And for the most part, that's the centroid of the lowest orifice and the spillway. Now, if you have ultimate condition or EURV or something, we talked about how that's a little bit different. Number 2, it is possible for a contractor to grade a pond to planned because I've had 6 out of 8 do it. Next takeaway, alternative but defensible evaluations may be used to certify the pond volume as necessary if your professional engineering judgment allows it to be called substantial conformance. So ultimately, it all comes down to you, and I am a big advocate for not, we know this from like any kind of legislation. You try to get too detailed, and it's just like you want to bang your head against the wall, and then in no way can you ever address all the situations that might come up. So whatever your judgment tells you, if you're going to stamp this, it'll suffice. And then refusal to certify may result in the need for you to defend your evaluation. Okay. Anything? We've got about half an hour. Anybody else? And I can, you can send questions to me through Rachel too, if there are any that I don't get to. All right, outlet conformance. UD detention is the most common. Familiarize yourself with UD detention. The Mile High Flood District, I believe, has a video.
Jesse, I put the link to the video in the chat. So
Okay.
Access that.
Great. The spreadsheet gives drain times for various, let me see if I can call one up here. So this is an example of, you can put, what is the stage? So again, the stage of 0 is the bottom, is the top of the micro pool, the top of the permanent pool. That's the centroid of the lowest orifice. And then, these are elevations above that. And then your square inches areas. You can put, you can put squares in here. You can put whatever areas you want to. But then it gives you, time to drain 97% of the inflow volume, time to drain 99% of the inflow volume. So it has, depending on the orifices you put in, you can mess with this and you can get different drain times, which is ultimately how we do it. Yeah, that's all I have to say about that. Oops, sorry. It does require a stage storage curve to be entered to reflect the proposed pond grading. So when you design an outlet using UD detention, you say stage 0, my surface area of my pond is X. Stage 1, my area is this. And you do that by grading it out and then measuring your contours for area as you go. And then this is that if desired, check to ensure the construction plans reflect the UD detention for orifice elevation and size, weir elevation and length, water quality capture volume elevation, and URV and 100-year as applicable. And then check to ensure the as-built reflect the construction plans. I mean, that's more important than, going from the design plans to the drainage report. But I did want to say that other outlet sizing calculations may be used. I'm still a fan of that. So you can Google orifice and weir equations if you don't remember them. But you always want to make sure that the design and the construction plans and the as-built conditions are all, more or less the same, if not exactly the same. So I just wanted to go through this example. This is the as-built that was provided, and there's no as-built elevations or dimensions. So this is the one that I requested the surveyed as-built. And I did note in the meantime, this is when I went into the UD detention, I thought, well, at least, these are 1-inch diameter and they're, what's the spacing? And the spacing in the UD detention did match this. So that was something that I could check. And then this is a figure we've already seen. This is what I got back. So this was like so super exact, you guys. The centroid in the design was 5350 and the AB was 5352. 52.67, 52.73. And then finally 52 and 52.05. So these are so close. He did a great job of building this. You would, I think for the most part, unless they're more than 1 inch off, it's probably fine. Like I said, we don't want we don't want it on upside down. So that, gosh, this invert was at 52 and it was supposed to be at 56 or 51. It's just stuff like that. But that's going to be one of those things that you have to use your judgment with too. Finally, certification or not, that is at the discretion of the professional engineer. There's a reason a specific tolerance isn't specified. I gravitate towards 5, but I'd also be okay with 7. You can, modify your calculation method to acquire little bits of more volume if you find that to be reasonable. And then the way water leaves the pond, I mean, that's the important thing, right? It should be generally consistent with the design. 1 inch or 2, 1 inch here or there is not typically critical, but more than that may be problematic. And then again, just refusal to do so. Sometimes it's just a matter of working together and, trying not to be, really dictatorial about it, and just talk with your CDOT counterpart that's managing construction and be like, look, man, I got to do this and it's not working out for me. So you can always offer it. If that person is a PE, you can always offer it to them to certify, I guess. I think that's all I got. We went really fast. We saved ourselves 45 minutes.
Tyler, go ahead.
Just a quick question. So you did all this. What does your certification look like? Are you stamping the as-built plan? Are you writing a letter? Like, what do you?
That's a great question.
How are you certifying it? Are you just
I
sending
haven't
an email?
certified anything yet.
Are you sending an email like, yeah, it looks good? I mean,
We have a form, Tyler. We
Okay.
have a certification form.
oh yeah, that form. Okay.
Yeah, the language, it's, to me, the language, it's a lot, it's very verbose. I don't think it needs to be that verbose, but some people like to add words.
We're still working on it, Jesse.
Okay. It basically just needs to say that, you know, the pond volume and the way water leaves the pond is substantial conformance with the plans. And there are some elevation entries, and, you know, after I reviewed I'm still working on KOA, guys, sorry. After I reviewed a certification that I got, I realized that that's not really how it should look. So that's in flux. But regarding my response thus far has been to email Rachel and Al and say, I can't certify this. I did do kind of like a brief memo about why. And then I said, like, you know, these 6 ponds are fine. But I haven't had to stamp anything. But ultimately, I think it is going to be a stamp.
Any other questions or comments? Jeremiah, I know you have an update about some training as well. You're welcome to provide that.
I think this is mostly for folks that might watch this after this meeting because it's being recorded. But a lot of what we've gone over, so a lot of the links that we've talked about from Mile High Flood District, they go over in a 2-day class provided through the Colorado Stormwater Center. And I'm putting the
Jeremiah, you're on mute.
Thank you.
Sorry.
Sorry.
Colorado Stormwater Center.
I'm putting the link in the chat is what I said. And just wanted to let everybody know that they go over a lot of these design concepts and why there should be in design. And I think what we've covered is, you know, we've gotten all the way through all of this and we're just making sure we got what we paid for. And I just want to thank Jesse, Al, Rachel, and Neil for sticking with this for the last couple of years, because I did not anticipate this being as big a deal as it has become. So many thanks to all of you for sticking this out with us.
I think this is just a little bit of growing pain. I think that after we do this a few more times and everybody knows what they need to send to who they need to send it to, I think it'll be streamlined more. I hope so.
Oh, and I was just going to add that headquarters pays for the 2 days CSU training. So that's just send us, all you have to do is go to that link. You register, put that you're with CDOT, and they send Rachel and I the bill.
That's pretty sweet. Good thing you guys don't have anything else to do, right?
And if anyone has additional questions or comments, then feel free to email me.
Hey,
Jeremiah
Rachel?
does. Yeah, go ahead.
I wanted to pose a question to the group. I think I asked the last group this, but I wanted to see what everybody thought about this tolerance level, this threshold level of 5%. I know Jesse's kind of framing it as, you know, this is engineering judgment, blah, blah, blah. I got that. But as an agency, I think we might have to take a little harder stance on that number, maybe. I know I see Jessie shaking her head. I'm just saying, you know, somebody comes in and audits us, Rachel, and
That's
somebody
a good point.
says, hey, why did you use 10% over here and 5% over here?
You're not.
You guys have a number.
The certification statement doesn't have that in it, and nobody's does. No example of certification statements on the internet that I have found has a percentage. You say it's in substantial conformance, and who is some English major from DC to question that? I know, somebody with
Well, Al, that's a great point, though. I wonder
That
if
is a good
anybody
point.
else who's in the meeting has any comments, thoughts about.
Yeah. I'd be curious to see
Specifying.
what others thought about that.
Al, I'll give
Hey,
you a
I
comment.
want to make it happen too, Jesse. You know, I want to get to yes too. Believe me, we've gone round on round on some of these. So
Al, I'll give you a comment. Hydraulics isn't that accurate.
hydrology.
Hydrology, yeah, and it's just not that accurate. So you're making a lot of assumptions all the way through the design, all the way to this thing's being built. And I agree with Jesse that there is some engineering judgment there of how you even calculated the hydrology. I mean, this is not an exact science. So,
I mean, your criteria manual allows for the rational method and CUHP. Those are going to give two wildly different values.
Yeah, exactly.
For runoff volumes, and yet they're both acceptable. So I don't know. It seems the equivalent, and I've used this analogy before. It seems like the equivalent to FEMA designating floodplains to the 0.01 foot. Like, come on, man.
Allison, did you have a comment?
I want to be able to use my engineering judgment and not have it set to 5%, because if it's 5.1,
yep,
I don't want to go there.
You know, I'm okay in that 5 to 10% range. Anything above that, then I start to have some concern, I guess.
The thing is, if you say no more than 10%, then you've got contractors saying, well, I'm at 9, like, come on. But maybe Allison's not comfortable with 9, maybe I'm not comfortable with 9, but
well,
if
that's what I'm saying. There's a lot of variation here depending on what region you're in.
No, I know.
Looking at this, you can have a wide range of numbers here. That's all I'm saying.
Yeah, I know. But I mean, my hesitation with even putting a pretty decent limit on it is that then now I'm getting pushback if I say no. 9.5% is not close enough.
Right.
And so now it's like, no. And then I got to fight. It's like,
right.
I don't want to fight.
Does anybody else in the meeting have a comment about tolerances?
Thank you, Rachel. I keep telling my comments.
I just throw my 2 cents in, Rachel, and I don't want to speak for you, but from like the auditor standpoint, I think once you get to that 5 to 7% realm, that's all we're going to be looking for. Rachel and I is looking for that rationale behind, why it is certified at 7%. Maybe it's 5 acre foot pond versus the 1/4 acre foot pond that's in the next basin over. So I mean, I think those are all things that go into that your PE stamp and your engineering rationale of, yeah, this is okay and I'm okay with it, and no, this isn't. And I think that's what Rachel and I are going to be looking for, is just, yeah, that you guys did that rationale behind, no, it's not good enough, or yes, it is. And I would say I will back any CDOT hydraulic engineer all the time if you're not comfortable with that, and we would go to bat with you and with you.
I agree. Absolutely, Jeremiah. We have 7 minutes. I want to make sure that people have time to ask any questions on the material that we've covered. I mentioned in the chat box a little while ago that I'm going to investigate using some mitigation pool fund money to essentially protect us in the gap, so that whether or not it's a CDOT region hydraulic engineer or it's a consultant who's going to be completing this pond certification form, that we do have an opportunity to connect with an on-call consulting hydraulic engineer. We realize that this is going to take some practice, and that it's it would be nice to have some support in that way. So I will review that possibility. I'll be in touch with the mitigation pool committee and let you know what their thoughts are. And yeah, Jeremiah and I are here to support you in whatever way we can. And we really appreciate all of the work that you've put into this already. This is going to help us really be able to ensure compliance for our MS4 permit. And we're grateful for that. Anything else? Awesome. All right. Well, Neil and Al, thank you so much for coordinating all of this. Jesse and Amy, we really appreciate you. And please reach out to Al and me if you have any other questions or comments or suggestions.
Thank you.
Thanks, everybody.
Thanks, Allison. Bye, everybody.
Bye, everyone. Bye.
Hey, Rachel, got a quick second?
I do.
I'm going to stop the recording.
Okay.
I think we're good.
Tyler, you gonna hang out?